So let's start with just a cubed plus b cubed. One of the factors is a plus b. I'll give you that to start. Now, it's not going to be a lot of guess and check like we saw factoring the trinomials. There's going to be a set rule we're going to follow each time. We use that rule, plug in the values. But I want you to see where it's coming from, where we could have something like a cubed plus b cubed end up. Now, what it's not going to be is a squared plus b squared times, or a plus b times a squared plus b squared. It's not going to be a difference of two squares. It comes up a little different. So just let's see that. I'm going to do a plus b in this box. And I'm going to think of my end result being a cubed plus b cubed. So I started with some a plus b, multiplied it by something to get to this end result. We're kind of taking it apart to see where this comes from. Now, we already know that a cubed and b cubed likely started top left corner, bottom right corner. But we don't have any other terms left to kind of distribute there. But let's kind of build it up and see what happens. So if this is b cubed, what is this? Okay. What would we go here then? AB squared? All right. What do you think goes here? Okay. What would go here? I mean a squared b? Now, we want, I heard AB. We want AB to go here. Does it fit though? If we put it here, this would then be a squared b, which doesn't, I'm not going to say cancel, but doesn't make 0 out of this. If we put that there, this also becomes ab squared, which doesn't become 0 with that. But what can we do to this? All right, let's make it negative. Now we got negative a squared b. We got negative ab squared. And those are wiped out. So we found, by doing that, the other factor was a squared minus ab plus b squared, which is the correct factor.
Did you make the AB at the start or subtract each other? And then make the a squared?
It would change the a squared and the b squared to also be negative. Okay, now, this is the end result. We'll start to put that together in a minute, but I want to see it again using the multiplication. So we'll kind of do it again. So I've kept this. That was from the first screen. Now let's think, what if it was a cubed plus 8? Okay, it's going to be two factors. What do you want to guess the first factor is?
A plus 2.
A plus 2. All right, we'll try that. So if that's a plus 2, we know we got a cubed there, 8 there. Let's fill in some values. What goes here? A squared. How about here? So then we got 4a, 2a squared. Okay. What do we want this to be? What does it need to be?
Negative 2a, 2a.
Yeah, because it has to be 0 with that. Which means this has to be. Okay? Which means we're going to have what right here? So it's going to become a squared minus 2a plus 4. Now, if you're looking at this going, do we seriously have to do the box every time? No, you don't. No. No. I want you to understand how this can end up to be so few terms, or if I start with just 2 terms like this, we're breaking it apart. This is the rule we're going to use. Okay? Now, let's look at the difference between these two. I have a, that stays. This was b cubed, that was 2 cubed. Right? Both of these started out with taking the base of these, as if we said this is a to the third and this is 2 to the third, and just making the first term those 2 values. Then we went the first term, the a, squared. The last term here was the last term squared. And then here was the 2 of the terms together, either 2 and a or a and b. So there's some patterns showing up there. So, if I looked at this one, a cubed minus 1, I meant to erase that answer. This is, as we say, a to the third and 1 to the third. So seeing where the pattern is holding up, this is still the first one. It's a minus 1 where we had a cubed minus 1 cubed. So that stays. We pull that one out. That's an easy one. Then the trinomial that's multiplied to, the first one squared, a squared. The last one squared, 1 squared. And then the middle term was the 2 of them together this time. A and 1. Or just 1a or a. Okay? I'm not worried about the signs, plus or minus yet. We'll get to that next. But this is where we just start pulling the values. I'm not looking at this going, what do I multiply to add to and breaking it up into grouping? It's looking at what your bases are here, plugging them into the right spots. That's all it is. It's not really complex factoring. We just got to put in the right places. Now, we do that. You look for the cubes, you look for whether the values or variables, whatever the case may be, you plug those in. We have to realize, though, when some are addition and some are subtraction, things are different. So, here are the 2 rules for sum of cubes and difference of cubes together. I would write these. These are the ones you want to circle. These are the rules that you need to have memorized. So like we already started to notice, a and b showed up here, a and b, a squared, there's b squared, there's the 2 of them together, shows up in both. But there's some differences looking at the signs. So this plus was the same, this minus was the same as the one we started with. If it was an addition with the cubes or a subtraction, that sign held up, either saying positive or negative. This one, when it started as positive, became negative. This one, when it started as negative, became positive. So it was the opposite. Then the last one, it was always positive. So it would be nice if we had a way to remember this. Not so much of when it started out as positive or negative, but anytime, if we could remember when we had the same, the opposite, or the sign was always positive. If only there was like a word we could remember. I don't know. Well, maybe we'll come up with something.
So after.
Or so AP. Like talking about your classes. That test was hard. Yeah, it's so AP. Or soap. So this tells us the signs. You're going to get a problem that you're going to have to factor. You figure out what the bases are. You distribute those out where they go. You go back and fill in the signs. It's factored. It's done. Most of the time. For all that we're worried about, this won't even factor, this trinomial. So it's taking that and breaking it into the 2 terms. That's all we need to do. Making sure the negatives are in the right place. So this is what we use. Don't use multiplication. We did the multiplication to see what's happening. That's how we get down to those terms, but these are what we'll use. So, I got k to the third and 27. We should think of that as k to the third and 3 to the third. Don't think of it as 27. You want to think of the cube. So, what's my first term? What's going to have in it? It's going to have a k and a 3, right? Then the second term is going to have what first? Yep, k squared. It's going to end with 3 squared. And in the middle, it's going to have one of each, which is 3 and k. Then we go back. It's same sign, opposite sign, always positive. Probably should do k plus 3, k squared minus 3k plus 9, just to clean up the squared. It's factored down. It's done. Don't keep going. K squared minus 3k plus 9 does not factor. We cannot multiply to 9 that adds to negative 3 nicely. So we don't even have to worry about that.
Just too many numbers.
Okay, look at the next one. What is that to the third?
7 and 12.
7x to the third.
Yes.
Okay? 64 is what to the third?
No, 4.
Okay, we have the pieces we need. 7x and 4 are the ones we're going to fill it up with. Then we go back and do the signs when we're done. So we start with each term. Next parenthesis, it's first term squared. We put in the last term squared. And in the middle, the two of them together. We will. I'm just distributing them out, then we'll multiply it, simplify it. Now, our signs. It goes negative, positive, positive. And that's because we started with subtraction. So same sign, opposite, always positive. Now 7x minus 4 is good. What's the other trinomial going to be? No, you can't. Seven x squared is 49x squared. 28x plus 16. Which part? Whole thing? This squared is 49x squared. 28x, 16.
Oh, and then my friends make secrets.
28x cubed plus 128. Hopefully we look at it and see the x cubed there. It's probably a hint it's going to be 1. It is. But 2 and 128 are not perfect cubes. What do we need to do?
Factor out to 2.
Factor out the 2. How about that?
Thanks. Yes, you do.
Is 64 a good number for this?
No. Yes.
It is, because it is 4 cubed. So, what's my first term when I factor that?
I can do anything and just make it. Like x.
X plus 4, okay? X squared, plus or minus?
Minus.
Then what? Good. And? Four or 16? 4 squared, 16. Now the 2 stays out front. It was factored out. It was a common factor. We leave it there. It's part of our answer. Okay, now 15w cubed minus 15. We go, oh, perfect cubes. That means the cube root of 15 is 5, right?
No. Yeah.
No, that'd be division. Not the same. What comes out? 15. W cubed minus 1. One of those great problems that has 1 as the factor to be 1, 1 squared, 1 cubed, any value. All right, I'm factoring that. What's my first term?
W minus 1.
Yep, same sign. Okay?
W squared plus 1W.
Good. Okay, this doesn't factor. W squared plus W plus 1. I can't multiply to 1 to add to 1. Later on, we could factor it, but it's not a real solution. It doesn't work for us. So that's what you're going to need to do. Factor it down. Your assignment? Two through 12 even, 13 through 14. You can get working on these. I can now pause the video because I stood over here so Cullen wouldn't talk during the recording.